your books. These were equations we were solving, where in some cases we had a square root or two square roots in the same equation that we had to solve. Remember that?
Uh-huh.
And remember the technique was to do what?
Square both. Move it to both.
Move it so that there's a square root on each side of the equation, and then solve.
Uh-huh.
Okay, so we're going to do something similar to that on some of these. Okay, so let's start with problem 2. This is a pretty simple one. So now we're back on page 234, 9.9. Now this is pretty simple, but what would you do here? Well, what if you subtracted 2 times the square root of x from both sides? What am I going to be left with?
Just square root of
X equals the square root of x, right?
Yeah.
And then if I square both sides, well,
You're gonna get X.
if I square both, let's see. Let me square both sides. So I'm left with x squared equals x. And now what if I divide both sides by x?
X equals 1.
X equals 1. Which makes sense, right? 1 plus 2 times the square root of 1 is 2. 1 plus 2, 3 times the square root of 1 is 3. So 1 plus 2 is 3. That one was pretty simple. Let's try another one. Let's try on that same page, problem 4. Do you have a question on that?
What? No, so you wouldn't leave it as X equals the square root of X?
The answer is x equals 1. That one, if I
Okay.
can get a number. Alright, so then number 4 is square root of 2x minus the square root of x plus 1 equals 3. Right?
3 over x squared.
Oh, I'm sorry, 3 over square root of x plus 1. Alright, now in this one, what does your instinct tell you to do here? Well, what if I multiply every term on both sides by the square root of x plus 1? Right? Because that'll get rid of it in the denominator. Yes. Right? So it'll be square root of 2x times square root of x plus 1 minus square root of x plus 1 times the square root of x plus 1 will just be equal to 3. I can do that, right?
Uh-huh.
So then, I would be left with I can remember when I have these, I can multiply this out. So this is 2x squared plus 2x, right? If I multiply this,
Yeah.
2x times x is 2x squared, 2x times 1 is 2x. Then I know if I multiply these, what am I going to get? X plus 1, right?
Yeah.
Equals 3. Everyone with me?
Yeah, I just messed up on this, one of these steps.
Alright. Then I'm going to bring this over to this side. So 2x squared plus 2x is equal to 3 plus x Actually, this should be like this, shouldn't it?
Yeah.
So it's going to be
2 minus x.
plus 1,
Or,
right?
oh yeah.
All right. Then what do I do?
To the
Well,
square
let me
both
first of all
sides.
let me rewrite this side. This is going to be what? X plus 4, right? And 2x squared plus 2x. Then if I can square both sides, right?
Yeah.
John, what do I get if I square the square root of 2x squared plus 2x?
2x squared plus 2x.
Yeah, that's right. 2x squared plus 2x. And what will this be?
It'd be
X squared plus 8x plus 16. Everyone see that? Okay. So then, this is just my choice. I'm going to bring everything over here. So I'm going to subtract x squared, 8x minus 16 from both sides. So it'll be 2x squared plus 2x minus x squared minus 8x minus 16 is obviously equal to 0, right? Now let's combine terms. What do I get?
X squared
X
minus
squared
6x
minus 6x
minus 16 equals 0.
minus 16 equals 0.
That factors
Okay.
to x plus 2 times x minus 8.
x, very good, x plus 2 times x minus 8 equals 0. So either x equals negative 2 or x equals 8. Now I did that last step kind of quick. So then now here, this is important on this. When you get to this step, you have to try both numbers in the original statement of the problem. Now look what's going to happen if I put in negative 2. I'm going to get the square root of negative 4.
Imaginary number.
I can't do that. So this answer is not right, is invalid. Right? But if I put in x equals 8, I'll get the square root of 2 times 8. Well, the square root of 2 times 8 minus the square root of 8 plus 1 equals 3 over the square root of 8 plus 1.
It'd be
Well, that's
4
going to be. I ran out of room.
minus 3.
I'm cheating here a little bit. That's going to be the square root of 16 minus the square root of 9 equals 3 over the square root of 9. Well, that's 4 minus 3 equals 3 over 3, or 1 equals 1. That checks. I ran out of room, so that got a little sloppy. Okay?
Okay. What do you want us to do on this?
Let me just stop that. A lot of crazy multiplying here. Problem 8 on page 234. Look at that one. What do you think you could do to solve this one?
Cancel out
What if you just took
the square root.
What if you just took the square root? Excuse me. What if you just squared both sides?
Or
Now think about that.
Never mind. Never mind.
Obviously, the square root of the square. Let me start again. If I square the square root of 5 minus x, and I square that, I'm going to get 5 minus x. But I could also do that to the 3 plus x. I don't have to multiply them first and then square and then take the square root. I can just do the square root of 3 plus x squared, which is 3 plus x. Do you see that? Yeah?
could you divide both sides by the square root of 5 minus x?
No. Because you don't have the square root of 5 minus x. You have the square root of x minus 5. On both
Yeah,
sides.
that's what I was about to
okay.
say. I saw that.
Yeah, I mean.
Okay, so see, that's an approach to number 8, right?
So just square both sides.
Square both sides. Now, look at number 6. What would you do with number 6?
Subtract 25. Subtract one of the square roots, so you have one on each side.
Right, then take the square, then square it. Okay, that's for number 6. Maybe I'll work that one on the board. That's similar to what we had been doing before. All right, let's look at a problem like number 10. What would you do for a problem like number 10? Well, here I'm afraid it's just going to get messy. There's really no clean way of doing this. But for number 10, you can put one of the square roots on the other side. All right, so let's go back and let's work problem 6 first, and then we'll work with problem 10. All right?
Okay.
Let's stop here. Just stop that, Lorraine.